Hey everyone, today we're going to be solving 3 questions from topic lessons 4.4 and 4.5 from Calculus AB, and the lesson title is called Related Rates. Now in this question they told us that a model car travels around a circular track with radius 5 feet, so they're basically talking about this radius over here, which is basically equal to 5. They said, continued, let Z denote the distance between the model car and the fixed point that is 20 feet to the left of the center of the circular track. So if you're counting the center of the circular track and you're going 20 feet to the left, they're basically talking about the origin. Because if you noticed, the circular track has a center of 20, oh. So if you're going to go to the left by 20 units, you're just going back to the origin. And the position of the car at the point xy. So basically they're saying that this point is the car and it's rotating around the circular track. Now, they continued and said Z is the length of the line segment from the origin to the point xy. So basically this line segment over here is denoted by Z. If x and y are functions of time, what is the rate of change of z when x is equal to 23, y is equal to 4, and the derivative of x with respect to t is basically equal to 2? Now notice at the end of the question they also gave us the equation of the circle, which is x minus h plus y minus k to the power of 2 is equal to radius squared. Now, they will never give you a piece of information without you using it. That's something that you have to put in your mind. So first of all, we're going to start this question by realizing that the distance between O and xy is given by z. So we have to use the distance formula over here to represent z, to express z. So basically we can say that z is the square root of x minus 0 to the power of 2 plus y minus 0 to the power of 2. 0 being the origin that we're talking about, because they both represent the center of the system. So now it is basically z equals the square root of x to the power of 2 plus y to the power of 2. So this is basically the function that we're talking about. Z of t is the square root of x squared plus y squared. So since they're talking about finding the rate of z, that means I have to differentiate this equation over here. So I'm going to reform this function to make it look like x to the power of 2 plus y to the power of 2, all of it to the power of half. So now if we derive it, the half comes down, x to the power of 2 plus y to the power of 2. We subtract one power from the function, so it's going to be to the power of minus half. And then according to chain rule, we have to multiply whatever is inside, that means whatever is over here, by its own derivative. So basically it's going to be 2x dx over dt plus 2y dy over dt. Now, you can literally stop over here and look at your given, because they already gave you the value of x, they already gave you the value of y, and they already gave you the value of dx over dt. So let's fill in these values. So now we have dz over dt equals half. X to the power of 2 is basically 23 to the power of 2 plus 4 to the power of 2. Everything is to the power of minus half. And then we have to multiply it by 2 multiplied by 23 multiplied by dx over dt plus 2y dy over dt. Now, before you come into calculation, just notice with me for 1 second that you have two unknowns over here. Basically, you have the dz over dt, and then you have the dy over dt. So you have one unknown over here, and you have one unknown over here. So now we have to work on how to find dy over dt. This is where the equation of the circle comes into play. Because if you write this equation of the circle, x minus h to the power of 2 plus y minus k to the power of 2 is equal to r to the power of 2. Now, if you replace it with the proper center and the proper numbers for h, k, and r, since h is going to be 20, since the circle is at 20, 0, so now we can say that x minus 20 to the power of 2 plus y to the power of 2. I didn't write y minus something because the ordinate of the center is basically 0, so there's no reason to do that. Equals, what is the radius? The radius is basically expressed in the question above, which is basically 5 feet. So 5 to the power of 2 is going to be 25. Now, if you derive this equation over here implicitly, you're going to get, so deriving it, you're going to get 2 multiplied by x minus 20 multiplied by dx over dt according to chain rule, because you're multiplying by the derivative of whatever is inside, plus 2y dy over dt equals to 0 because the derivative of 25 is equal to 0. So now if you replace all of the given values that you have from the question, you are able to find dy over dt. So as we said that x is equal to 23, so 2 multiplied by 23 minus 20, and dx over dt is basically equal to 2. So you're going to write over here multiplied by 2 plus 2, y is equal to 4, and you have dy over dt over here equal to 0. So this will give us that 23 minus 20 is equal to 3, and 3 multiplied by 2 is 6, multiplied by 2 is going to be 12, so 12 plus 8 dy over dt is equal to 0, which is going to give us dy over dt equals to negative 12 over 8. So now, coming back to the original equation that we left off over here with the differentiation of z, we are able now to replace dy over dt with negative 12 over 8. So now let's rewrite dz over dt. So we have equals, one second, all right, equals to half 23 to the power of 2 plus 4 to the power of 2, all of it to the power of minus half, 2 multiplied by 23 multiplied by 2 multiplied by 2 multiplied by 4 multiplied by negative 12 over 8. So now using your calculators, you can easily find all of these values over here. Now, first of all, let's start with the 23 to the power of 2 plus 4 to the power of 2. This is going to be 545. So it is going to be dz over dt equals 545, all of it to the power of negative half over 2, multiply 23 times 2 times 2, 92. And over here, 4 times 2 is going to be 8, and then 8 and 8 are going to cross each other out, so it's going to be minus 12. Then you're going to be left off with 92 minus 12 is going to be 80, and 80 divided by 2, which is this 2 over here, is going to be 40. So the answer is going to be 40 over the square root of 545, which is basically letter B. So 40 over the square root of 545. Now notice that part B and part C, like choice B and choice C, actually, they are literally the same exact answer, but one says that the model car is moving away from the fixed point at a rate approximately 1.7 feet per second, and the other one is saying towards. Now, if it was actually towards, that means the distance is going smaller, and if the distance is going smaller, that means the derivative should have been negative. But since the derivative was positive, that means it was moving away. So this is it for the first question. You can pause this video whenever you want and recheck all of the steps. Now coming to question number 2. In question number 2, they said a triangle has a base x meters and height h meters, where h is a constant and x changes with respect to time, measured in seconds. The angle theta measured in radians is defined by tan theta is equal to h over x. Which of the following best describes the relationship between d theta over dt, the rate of change of theta with respect to time, and dx over dt, the rate of change x with respect to time? So basically they want a relationship between d theta and dx, ultimately. So first of all, what I like to do first of all is basically draw an arbitrary right triangle. So they said the base is x meters and they said the height is h, and this is the theta that we're talking about. So they're telling me that h is constant, h is the same, and x is the one that is changing. Now I want you to imagine this in your head. Like x is changing. If it was over here, then this is how the triangle would be. But if it was over here, for example, then this is basically how the triangle would have been. Or maybe if it was over here, then this is how the triangle would have been. So you can literally animate it in your minds just to have like a clear image of what's happening. Now, we need to start first of all with tan. So we know that tan theta is equal to h over x. We know that h is a constant and x is a variable as a function of t. So we know that x is a function of t. Now, in order to have an expression of theta by itself, we have to introduce arctan because we need to remove the tan. So theta is equal to arc tan h over x. Now, if we are going to derive theta, so we need to find d theta over dt, we're basically dealing over here with an inverse trigonometric function. So I'm going to call this arc tan u. So now if we want to find d theta over dt, we're basically deriving the inverse trigonometric function of the form arc tan u, which is going to be du over dt over 1 plus u to the power of 2. This is basically a formula that you guys need to know. This is like the general form of this derivative. But we don't have u, right? We have basically h over x. But what it basically means is the numerator is going to be the derivative of h over x. And the denominator is going to be 1 plus h over x, all of it to the power of 2. That being said, the derivative of h over x, since x is the function that we're talking about, and h is a constant, that means we're literally finding the derivative of 1 over x. Now, the derivative of 1 over x is going to be negative 1 over x to the power of 2. If you don't know how to derive 1 over x, just replace x from the denominator to the numerator and change the exponent to minus 1. So basically, we are moving 1 over x, and it's going to become x to the power of minus 1. So after you derive x to the power of minus 1, you're going to get minus x to the power of minus 2, which is essentially minus 1 over x to the power of 2. So it is going to be minus h over x to the power of 2. But since x is a function of t, if we want to apply chain rule, we have to multiply this derivative by dx over dt over 1 plus x to the power of 2. Now, x to the power of 2 is able to multiply the denominator over here because over here you have a fraction in the numerator. So the denominator of the numerator, what it means is basically if you have minus h over x to the power of 2 divided by 1 plus x to the power of 2 over, basically divided by 1 over x to the power of 2, you're going to get minus h over x to the power of 2 multiplied by 1 over 1 plus x to the power of 2. So the x to the power of 2 can safely go down in the denominator side. So you're going to get d theta over dt equals minus h dx over dt over x to the power of 2. Oh, over here I made one tiny mistake. This is not basically x to the power of 2. This is, okay, this is basically 1 plus h to the power of 2 over x to the power of 2. So now x to the power of 2 multiplied by 1 is x to the power of 2 plus x to the power of 2 multiplied by h squared over x squared. The x to the power of 2 can cross each other out, and then you're left up with h to the power of 2. So just make sure that this is in brackets. So you're going to distribute x to the power of 2 to both pieces, the 1 and the h squared over x squared. Now, if you isolate dx over dt, you're going to get minus h over x squared plus h squared multiplied by dx over dt. That is going to give you choice number A, part A. So choice letter A is the correct answer over here, minus h over x squared plus h squared dx over dt. Now, the final question over here is literally the same exact question, but this time it's a little bit easier. They're telling you that x is the constant over here and h is the one that is changing with time. So if we draw our random triangle over here, again, I would like you to imagine the scenario over here, because if x is constant and h is changing, that means that the triangle could look like this or like this, like it's going up or down, you know? So applying the same exact technique, tan theta is h over x, which means that theta is arc tan h over x. So deriving it, we're also going to use like u prime over 1 plus u to the power of 2. But this time, h is the one that is to the power, like as a function of t, and x is basically a constant. Now, it's easier to derive it because now, since h of t is in the numerator, I don't need to move anything from the denominator to the numerator because it's already given. So now, d theta d theta over dt, it is going to be 1 over x multiplied by dh over dt, because h is to the power of 1, so it's going to be 1 over x multiplied by dh over dt, which is according to chain rule because we're dealing with a function rather than a variable, over 1 plus h squared over x squared, or essentially like h over x, all of it to the power of 2. So now, if we bring down the 1 over x, the x essentially, so it will be 1 over x plus h squared over x. Now, all of it multiplied by dh over dt. Now, if you notice over here, none of the answers looks exactly like my answer over here. So don't panic. Now, over here, you have a chance to make a common denominator, and I advise you to do that, because if you do, you're going to notice that it will be one of the choices above. So now, equals 1 over, so if you do a common denominator over here, essentially you're going to get x to the power of 2 plus h to the power of 2 over x, all of it, dh over dt. Now, essentially, you have 1 divided by x squared plus h squared over x, right? According to the fraction that we have in brackets. So keep, change, flip, 1 multiplied by x over x to the power of 2 plus h to the power of 2. You're going to get x over x squared plus h squared, which is going to be x over x squared plus h squared dh over dt. And this brings us to choice A again. So in this question, the answer is A. And the previous question, the answer is also A. Okay, so this is it, guys. If you have any questions, you can pause the video whenever you want. Comment on this video if you have anything for me to repeat for you. Thank you.